This is code to do a genome-wide association study using single sequence strain and with lifespan measured by flow cytometer. The lifespan measured by flow cytometer is basically membrane integrity measure of chronological lifespan. So I first read in the genotype data, and I then read in the phenotype data, which is the lifespan. I then use the match function to merge the genotype and the phenotype data. The match function is down here. I took I call the lifespan data called data. I basically match the string yeast strains to as the row name for the data, for the lifespan data. I then partition the lifespan into 3 groups. The long lifespan, which is longer than 42 days, and short lifespan is shorter than 16 days. The remaining lifespan, I call it average lifespan. I then basically loop over every genotype, every locus in the yeast genome. For every locus, I first found out that the genotype, and I then partition the genotype and the lifespan based on the 3 categories. So I will have for every genotype, I have the lifespan category. So then you have a genotype in one row and lifespan in one row. That will be a 2-way table. I then apply something called Fisher's exact test. That test will give a p-value. If it's very small, that will show that the genotype will have the lifespan is unevenly distributed among those genotype categories. And then we say maybe then we say there's an association between lifespan and that locus. I do this for every locus. This is actually a very intense computing, so I add something here. So for every 1,000 genotype, I output a temporary result. This is also helpful when I'm doing a long run and the computer breakdown, computer freeze. I can still have temporary data saved there. So when I come back, I don't have to restart from the beginning. I can see my temporary data, or if it stops at 10,000, I can start at 10,001. Right? So I don't have to repeat my previous work. This is just a trick I learned from my own mistake. But if everything runs fine, I write everything also to a final file. So if everything runs smoothly, there's also a final file output. Okay.